Okay, let's just do a few revision questions. Target shown is 1 metre by 1 metre. Inside the square are a grey circle of radius 0.5 and a smaller black circle of 0.2. Okay, so let's think about that. The bigger circle has got an area of 0.5 pi r squared, so pi times 0.5 squared. So that's the grey. Here I should do it in grey. My black circle has got a radius of pi r squared, which is pi times 0.2 squared. Suppose that a dart is thrown, the total area of the board is 1 metre squared, isn't it? 1 by 1. Probably the dart will hit the black region. So what's the area of my region? So the area of the black over the total area is the probability of hitting it. So the area of the black is 0.2 squared, which is 0.04 pi over 1, which is the area of the board. So we get 0.04 pi, which is B. What's the probability that hits the grey region? Well, think about that one. So what is the area of the grey region? So the area of grey is equal to, well, it's the 0.5 squared times pi minus the area of the black, which is 0.2 squared times pi, which is pi times, well, 0.5 squared is 0.25 minus 0.2 squared, which is 0.04, 0.21 pi over the total area, which is 1, which is D. Don't forget you've got a calculator for these though. What's the next one? Suppose 10 points are awarded if the dart hits the black region, 5 points if the dart hits the grey, and 0 if the darts, 2 darts are thrown. The probability that the total score is 10. 2 darts are thrown. Which means, so what does that mean? So I've got to get 10 points. So how can I get 10 points? So I hit the black, so I need the black and a complete miss, or I need a grey and a grey. Yeah. So a black, what's the probability of hitting the black section? Well, I've worked that out. It's 0.04 pi, isn't it? 0.04 pi times, well, what's the chances of hitting the white section of the board? Well, the white section of the board is the total area, which is 1, less the grey and the black together. Okay. And the grey and the black together is 0.25 pi. So that's that section. So not 0.25 at all there. So it's 1 minus 0.25, which is 0.75 pi. Or, so plus the grey sections. The grey section was 0.21 pi times 0.21 pi. So if I use my calculator here, 0.04 pi times 0.7 pi is 0.03 pi squared plus 0.21 plus 0.21 times 0.21 is 0.0441 pi squared. So if I add them together, I get 0.0741 pi squared, which is C. So part of the trick also was not keeping it in terms of pi, seeing that the multiple choice responses were in terms of pi, so not evaluating pi as 3.141, etc. All right. Question 4, we've got 60 teenagers are asked what they did on weekends. Total of 45, so they went to the beach or movies or both. 22 went to the beach, so they also went. All right, so it looks to me like it might be easiest to do a Venn diagram. So we've got beach, movie, probably not the biggest thing over there. Right, 60 teenagers after a total of 45 said they did something. So that means 15 did nothing. Of the 22 who went to the beach, 12 said they also went to the movies. I think we've done this question. So that's a 12, which means that's 10 because that's all the beach. Movie people. So what have we got? So 10 and 12 is 22. So there must be 13 movie people because it's got to add to 35. So if you add up all the areas, I got 10 plus 12 is 22, plus 13 is 35, plus 15 is, 23. It only adds to 50. So there must be 23 people that went to a movie on its own. All right. 23, 35, 45 people in total went and saw something in the circles. Right. Find the probability that the student went to the movies but not the beach. So how many went to the movies but not the beach? There were 23 of them. So for A, we can see that that's just 23 out of 60. B, the student did not go to either. Well, we can see that that's the 15 off to one side. 15 out of 60, which if you can notice is 1/4. All right. Last couple. Given an experiment written as such, find. Okay, so there's a few complements, there's a couple of conditionals. As soon as I see the complement, I tend to want to draw a table. A dashed, B dashed, and there's some totals there. All right, so what have we got? I've got the probability of A is 0.3, which means of A dashed is 0.7. Probability of B is 0.5, which means B dashed is also 0.5. And I've got A intersection B is 0.2. So if I fill in all the other gaps, 0.2 plus 0.1 is 0.3, 0.2 plus 0.3 is 0.5. A 0.4 there satisfies everything. So now, let's have a look. A union B. A union B is equal to, so let's do A over here. That's the probability of A plus the probability of B minus A intersection B. The probability of A is 0.3 plus 0.5 minus 0.2, which is 0.6. That's A. B is A dashed intersection B dash, which you can see off the table, is equal to 0.4. A given B is equal to A intersection B over B, which is equal to 0.2 over 0.5, which is equal to 2/5. And B given A is equal to B intersection A over A. And B intersection A is the same as A intersection B over the probability of A, which is 0.3, which is 2/3. Okay. Vince's football team wins. The 70% chance he'll go to the next game. If they lose, 90% chance he won't go for the next game. So Vince is a fair weather supporter. So let's have a look. They win or they don't win. All right. Oh, hang on. We've got to use their abbreviations. Let's get rid of them. All right. Show this information on true I'm using abbreviations as follows. Goes and doesn't go. Won the last game, didn't win the last game. So I think we can keep with win and don't win because whether he goes or not depends on whether they won or not. Yeah. So Vince's Vince's football team wins 40% of the time. So the probability of winning is 0.4. Probability of not winning is 0.6. If they win, there's a 70% chance he goes to the next game, which means a 30% chance he doesn't. If they don't win, there's a 90% chance that he won't go and a 10% chance that he will go. So there's the information. What is the probability that Vince's team lost their last game and he doesn't go to their next game? what's that saying? What is the probability that Vince's team lost their last game? So probability of lost and didn't go. Lost and didn't go. Oh, that's the same as not winning and not going, which is equal to 0.6 by 0.9, which is 0.54.